Hi everyone, and welcome to this video on adding and subtracting fractions. This is the part 2 video, and if you haven't watched part 1, I'd recommend that you go and do that now. I'm just going to quickly recap some of the things that we've covered in part 1. Firstly, the number on the top of a fraction is called the numerator, and the number on the bottom of the fraction is called the denominator. That's very important to understand because we're going to be using those terms a lot. When we add and subtract with fractions, we need to make sure that before we do the addition or the subtraction, that we have the same denominator for both parts of the problem, so that both fractions will need to have the same denominator. Sometimes they already have that same denominator in the problem, in which case you just carry out the addition or the subtraction with the numerators and you keep the denominator the same. When fractions have different denominators, you can multiply the denominators by one another to create a new shared denominator, and that's what the part 1 video was about. But don't forget that if you do that, whichever number you multiply the bottom of the fraction by is the same number you must multiply the top of that fraction by as well. In other words, if I multiply the denominator by something, I have to multiply the numerator by the same number as well. Keep the proportion of the fraction the same. Now, if that doesn't make sense to you, go back and watch that first video, because this one now is going to be talking about times when the two things we've already discussed, where they have already got the same denominator, or where we're going to create a new denominator just by multiplying the current denominators together, when those two things may not apply. So that brings us to finding the lowest common multiple. So we can always take those two denominators, as I said, and multiply them together. That will work to find a common denominator or the same denominator that will work for both fractions, and that will always work. But sometimes that's going to give us a really big denominator and a tricky number to multiply our numerator by. And also, sometimes it's not necessary to even change one of the fractions, so we don't need to be doing that every time. For example, if you look at the fraction on the screen, 1/2 plus 3/4, if we use the method that was explained in the part 1 video where we multiply the denominators together, then we'd multiply the denominator 2 by the denominator 4, and that would give us a new denominator of 8. But both 2 and 4 are actually factors of 4 already, so we can leave one of those fractions the same. We don't have to change them both. See here on my screen, I've got a visual representation. On the left-hand side, that fraction is 1/2, and on the right-hand side, that's 3/4. I can leave 3/4 the same, and you can see that I've drawn a line through the fraction that was 1/2 and split that shape into 4/4, which look exactly the same size as the parts of the fraction that are on the right-hand side. In other words, I can see already that I'm going to be able to break both these wholes up into quarters and still use all the parts that are shaded in my fraction. What I'm going to do is turn the other fraction, which was 1/2, into a fraction that has quarters, and I'm going to then turn the part that I've coloured in, the 1/2, when I had it split into 2 parts, and I'm going to make that 2/4, 2 out of 4. So I'm just changing the other fraction. So this one here is not changing, it's going to stay as quarters, and this one here is going to become quarters, and we're going to make that denominator match. So now we have two fractions with the same denominator of 4. I can go back. Whatever I do to the bottom of the fraction, I have to do to the top. So because I doubled my denominator, I had to double my numerator. So instead of 1/2, it became 2/4. 2 plus 3 equals 5. Remember, we don't change the denominator. I now have 5/4. So if we go back to this picture, if you imagine these are all the quarters, 1, 2, 3, 4, 5. I would have, if I put this one segment here over here, that would fill my entire one whole and leave this bit left over. So it makes sense that my answer is going to be bigger on top. The numerator is going to be larger than the denominator. So I actually have 1 whole, and now I have 1/4 left over. All right, What if we can't use that method though? What if one of the denominators isn't a factor of the other denominator? For example, this one here, 5/6 take away or subtract 3/8. Now, we could use that method where we multiply the denominators together. I could do 6 by 8, which gives me 48, and then we'd have big fractions that we'd be working with and we could simplify our answer. But instead, we could find a lower denominator that will work for both numbers. And to do that, we find what's called the lowest common multiple. So to find the multiples of a number, I'm just going to list the numbers here that if I multiply that number out. So I've got 6, and I count in sixes. These are going to be the multiples of 6, 6, 12, 18, 24, and 30. These I just did the first 5 multiples. So for 8, 8, 16, 24, 32, 40. And I see that both of those numbers are factors of 24. Or in other words, 24 is a multiple of both numbers, and it's the lowest one that's a multiple of both. 6 times 4 gives me 24, and 8 times 3 gives me 24. So we're looking for a number that is a multiple of both 6 and 8, and that multiple is 24. Sometimes you might find there's more than one multiples that would match. So we're looking for the lowest one when that happens. Okay, so now that I've worked out that I'm going to use that 24 as my new denominator, I have to make the numerator match the new denominator. So I'm going to take that 6 times 4, and I'm going to remember the rule that whatever we do to the bottom of a fraction, we also have to do to the top. So I'm multiplying my 6 by 4 to get my 24, which means I have to multiply my numerator by the same number. So 5 multiplied by 4 will give me 20. So my fraction, which was 5/6, is now 20 24ths. Same thing with the denominator that was 8. Remember, this time it was only 3 8s to get to 24. So I'm going to multiply 8 by 3 to get to 24. And whatever you do to the bottom, you have to do to the top. So I'm multiplying 3 by 3 as well to get to 9. So 3 8s is equivalent to 9 24ths. Now we can complete the operation. I've put the two new fractions in here. 20 over 24, take 9 over 24. Remember, we leave this denominator the same in the answer. And the working that we're going to do, in this case, the subtraction, I'm going to do with the numerators. So 20 take 9 would give me 11. So my answer would be 11 24ths. I hope that was helpful. If so, please like the video. Don't forget to subscribe to the channel and hit the bell so that you get notified when new videos come up. Thanks guys. Bye.